Alright guys, so the next unit or lesson that we're going to look at is 7.3, which has to do with proving a quadrilateral is a parallelogram. So you guys learned in the last lesson that if you have this happen or if you're given a parallelogram, then you know this. So now we're going to be given some information and we're going to have to prove that it is a parallelogram. And so what I'm going to do is I'm basically just going to explain some quick theorems that are going to help us to determine this. So the first one we're going to look at is theorem 7-5, which states, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So basically, if you have a quadrilateral here, and the opposite sides are congruent to each other, then automatically that tells me, boom, this is indeed a parallelogram. So again, if opposite sides of your quadrilateral are congruent to each other, then that proves it is a parallelogram. Next theorem we're going to look at is 7-6, which is proving the same thing as a quadrilateral is a parallelogram. So if you're given a quadrilateral and 7-6 states, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So like the last one, the sides were congruent. Now we're going to look at the angles. So let's go ahead and say this angle right here has one arc, and this angle right here has one arc. That means those two are congruent. Opposite angles. Then I'm going to look at these two. Let's say this one has two arcs, and this one has two arcs. That means those are congruent. So boom, because the opposite ones are congruent, the opposite ones here are congruent, that proves that this quadrilateral would indeed be a parallelogram. So the next one is going to be theorem 7-7, which theorem 7-7 is doing the same thing here, and I'm going to go ahead and read it to you. So 7-7 states, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So that means if I was to take a line and connect it from here to here, and I was to take another line and connect it from here to here, those are going to basically cross each other. But the diagonals of this quadrilateral, if they bisect each other, meaning they cut each other into two equal pieces. So this line is going to cut this line in half, and this line right here is going to cut that line in half. It's going to cut them into two equal parts. If they bisect each other, then that means that is a parallelogram. The last one, theorem 7-8 states, if one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. So that tells me if I take one pair of sides, so in this quadrilateral, let's say both of these, top and bottom, if this line and this line are both parallel and congruent to each other, then that means this is indeed a parallelogram. So that's only one pair. So if you have one pair of sides that are parallel to each other and congruent to each other, then that automatically tells me that this is a parallelogram. So we're going to take all these theorems and we're going to basically use them to define if it's a parallelogram. Then we can take the information we learned from the last lesson to answer problems and figure out problems using the definitions of parallelograms. Okay, so now we're going to look at an example real quick, and we're going to use the theorems that we just learned about to try and prove if these quadrilaterals are going to be parallelograms or not. So right now, let's go ahead and look at A, and we're just going to analyze and look at what's happening here. So right now at A, we just have a diagonal line, and then we have two sides that are going to be equal to each other. Okay? So earlier we learned on 6.5 that opposite sides have to be congruent. Are opposite sides congruent? No. Okay? Next thing we learned were the opposite angles have to be congruent. Well, it says nothing about the opposite angles being congruent. The next thing we learned about are the diagonals have to cut each other in half. I don't have two diagonals cutting each other in half. And the third thing we learned was there's one pair of sides that are parallel and congruent. So none of those four things fit this shape right here. So this is going to be a no. This is not a parallelogram. Okay? So now looking at B here. So now it looks like I have a rectangle here, and it looks like I have two diagonals that are going across from each other. But earlier we learned in a theorem that if I have two diagonals, they have to bisect each other, meaning cut each other in half. So what that means, if this line is going to cut this line in half, this piece has to be the same measurement of this piece. Well look, those aren't equal to each other. This piece right here would have to be equal to this piece. Those are not equal either. The angles are not congruent to each other, and my opposite sides are not congruent to each other. So this is going to be a no as well. It is not a parallelogram. Okay? So now let's look at C. So looking at C, the only information I'm given is this side is parallel and congruent to this side is parallel and congruent. So the opposite sides, one pair of opposite sides are parallel and congruent. So this is going to be a parallelogram because of my theorem 10-8. So this is going to be a yes. Okay? And then lastly on D, I'm not given any angles, I'm not given any diagonals, I just have these opposite sides are congruent. So in order for it to be a parallelogram, I have to have a parallel and congruent one pair, or both of these have to be congruent on both sides. So this shape as well is not going to be a parallelogram. So then, if I knew it was a parallelogram, then I could use information to answer some more stuff on it, basically. Okay, so now on this example, I think it's number 2 on your notes, is we need to find the value of x and y that would make A, B, C, and D a parallelogram. So this is A, B, C, and D a parallelogram. So right now we know this is a quadrilateral, and it looks like we have two diagonals that are crossing each other. So we can go back to our theorem 7-8, and it basically tells us that these two lines would have to bisect each other in order for it to be a parallelogram. So that means this line would have to be congruent to this one, and this line would have to be congruent to that one. So I'm basically just going to take the equations, set them equal to each other, and find the value of x that would make these two congruent, and find the value of y that would make these two congruent. So I'm going to take 8x plus 12, and I'm going to set it equal to 10x minus 24. So these two lines have to be congruent. Then these two lines have to be congruent. So I'm going to do 2y minus 80 is going to be equal to y plus 9. So let's go ahead and solve our equations. So I'm going to subtract 8x on both sides, which is going to cancel over here. So I'm going to get 2x minus 24. I'm going to add 24 on both sides. Let's cancel over here. So 24 plus 12 is going to give you 36. Then I'm going to divide by 2. So 36 divided by 2, what is going to give me 18? So x is going to be equal to 18. Okay? Now I'm going to solve for y. So I'm going to go ahead and subtract y on both sides. So it's going to cancel over here. 2y minus y is just going to give you y. Then I'm going to add 80 on both sides. So 9 plus 80 is going to give me 89. So the value that is going to make both of these sides into a parallelogram and these two sides into a parallelogram is going to be x equals 8 and y equals 89. So that is going to create that quadrilateral, make it into a parallelogram. In this example, it wants me to prove quadrilateral EFGH to be a parallelogram. So right now what I can see is I have a quadrilateral and I have angles basically here. So one thing I can look at is all of these angles here in a quadrilateral are going to add up to 360 degrees. Because 75 and 105 is going to equal 180. And then I know 75 plus whatever this angle here is going to equal 180. So since all angles of a quadrilateral add up to 360, I can find this by adding all these up and subtracting it from 360, which would give me h is going to be equal to 105 degrees as well. So now, if I look, opposite angles are congruent, opposite angles are congruent. So since my opposite angles are congruent, I think that's going to be theory number 2 that tells me, or theory 7.6, that tells me opposite angles are going to be congruent, so that tells me it is a parallelogram. Check. It is a parallelogram.